Hello, my name is Ken Wilson. I am a retired water resources engineer. I live in Victoria, British Columbia. I have followed the work of the Intergovernmental Panel on Climate Change, the IPCC, for many years. I hope this video, the IPCC versus the facts, will give you a better appreciation of the natural forces that have driven climate change in the past and of how these same natural forces are still playing a role in climate change today. The video will also examine some effects that our species is having on climate change today. Our home. There is no other planet like it. It is a wonderful place. Can we preserve it? The present drive to adopt green energy measures and achieve the net zero 2050 goal poses major economic, environmental, technical, and political challenges to all nations in the immediate future. I am not going to go into details of these various issues today. Instead, I want to focus on the key claim by the IPCC and its supporters, that our species has become a threat to the survivability of life on our planet. This video will deal with the behavior of the Earth, the behavior of climate, and the behavior of our species. The presentation is in three parts. The first will deal with climate in the past, the second with climate in the present, and the third is a postscript listing some of the major shortcomings of the IPCC's executive panel. The IPCC is the United Nations body for assessing the science related to climate change. The IPCC was created in 1988. It issues summary reports for policymakers, SPMs, every 5 to 6 years. In 2021, the IPCC Executive Panel released its AR6 special report for policymakers. Antonio Guterres, the Secretary General of the United Nations, warned that the report was a code red for humanity. The alarm bells are deafening and the evidence is irrefutable. Greenhouse gas emissions from fossil fuel burning and deforestation are choking our planet and putting billions of people at immediate risk. Is this true? Or has the West talked itself into a climate hysteria that is being sustained by excessive green energy funding and by the flawed assumptions and flawed analysis of the IPCC's computer modeling studies? Our planet is a giant heat engine fueled by radioactive decay. The mantle below the Earth's crust is a semi-solid material that convects heat outward from the Earth's core to the Earth's surface. It causes the tectonic plates that the continents are embedded in to drift. Sometimes the plates collide, sometimes they divide. Sometimes the moving tectonic plates cause earthquakes, volcanoes, and mountain building. Figure 1 shows the Earth's temperature over the past 65 million years. The Eocene maximum 52 million years ago, was one of the warmest periods on the planet in the last 600 million years. At the Eocene maximum, the Earth was ice-free. The Indian tectonic plate was beginning to collide with the Eurasian tectonic plate. About 47 million years ago, South America began to separate from the Antarctic, opening Drake's Passage, allowing strong, cold circumpolar air and ocean currents to develop around the Antarctic. The Antarctic has the highest average elevation of all the continents. About 42 million years ago, the Indian plate, which was thrusting under the Eurasian plate, began to create the Himalayan mountain belt. This produced the monsoon conditions south of the Himalayas and the dry, arid plains north of the Himalayas that still exist today. About 33 million years ago, glaciation began in the Antarctic. Between 25 and 15 million years ago, tectonic plate rearrangement and mountain formation was prevalent. About 3 million years ago, the Isthmus of Panama was formed, connecting North America and South America. This cut off the warm equatorial current between the Pacific and Atlantic Oceans. This led to the creation of the Gulf Stream, which today keeps Northwest Europe as much as 15 to 20 degrees Celsius warmer in winter than it otherwise would be. Also, about 3 million years ago, the Alaska mountain range rose, reducing the flow of mild Pacific air into northern Canada. About 2.5 million years ago, glaciation began in northern Canada. 21,000 years ago, at the last ice age maximum, the Earth experienced some of its lowest temperatures in the last 600 million years. In summary, the location of continents and mountain ranges can be a major influence on how air currents and ocean currents redistribute the excess heat from the tropics to the polar regions. This affects both regional climates and global temperatures. Although the interior of the Earth is very hot, the Earth without any greenhouse gases would have an average surface temperature of about -18 degrees Celsius. There would be no life on the planet. With greenhouse gases, the average surface temperature is about +15 degrees Celsius. The temperature on the surface of the Earth depends on the amount of radiated energy that is absorbed by the Earth daily from the sun. Figure 2 shows the albedo, which is a measure of the reflectiveness of different surfaces on Earth to incoming radiation from the sun. Water, dark soil, forests can absorb a lot of incoming radiation from the sun. This warms the Earth. These surfaces have low albedos. Ice, snow, clouds can reflect a lot of the sun's incoming radiation back into space without it ever warming the Earth. They have high albedos. When a new ice age advance begins, glaciers and ice sheets begin to grow in size. Their local albedos become increasingly reflective. This is a positive feedback mechanism that accelerates the cooling process. In an ice age advance, increasing cloud cover can have a similar effect. If the summer sun cannot melt the snow from the previous winter, snow accumulates. If this continues year after year, glaciers and ice sheets begin to grow. Our current ice age has developed in a series of ice sheet advances and ice sheet retreats. We have had over 50 of these cycles so far. The timing of the ice sheet advances and retreats is determined by 3 Milankovitch cycles, which describe 3 different aspects of how the Earth orbits the Sun, as is shown in Figure 3. The eccentricity cycle on the left has a period of about 100,000 years, as the Earth's orbit becomes slightly more elliptical and then slightly less elliptical. When its orbit is at its most elliptical, the Earth is closest to the Sun, and it receives its maximum incoming radiation from the Sun due to eccentricity. The tilt cycle in the center has a period of about 41,000 years. It tracks the tilt of the Earth's polar axis from a minimum value of about 22.5 degrees to a maximum value of about 24.5 degrees. At maximum tilt, the northern latitudes receive their maximum amount of incoming radiation from the Sun due to tilt. The precession cycle on the right measures the wobble of the polar axis and its effect on the direction of the polar axis. This determines the timing of the seasons of the year. The precession cycle varies between 19,000 years and 26,000 years. About 21,000 years ago, at our most recent ice age maximum, the three Milankovitch cycles began to combine into a strong warming phase. This meant that the Earth was closest to the Sun due to eccentricity, the tilt was close to its maximum value, and precession caused the polar axis to be pointing directly at the Sun in mid-December. This maximized the incoming radiation from the Sun reaching the northern latitudes, and it maximized the summer melting of northern glaciers and ice sheets. Figure 4 shows more detail of our current ice age, which started about 2.5 million years ago. Each drop in the graph marks an ice age advance, and each rise marks an ice age retreat. In the first 1.5 million years of our ice age, each advance and retreat cycle lasted about 41,000 years. Tilt was a controlling factor. In the last 1 million years, each cycle lasted about 100,000 years. Eccentricity was a controlling factor. The longer cycles created more extensive and deeper ice sheets. Figure 5 shows the last 350,000 years of our current ice age. The red curve shows temperature, the blue curve shows CO2 concentration. The common pattern in the last 350,000 years is for brief interglacial warm periods to be followed by about 100,000 years of declining temperatures to reach the limit of another ice age advance. This is followed by a sharp rise in temperature to the start of another brief interglacial warm period, which in this case is the Holocene interglacial that we are currently living in today. The preceding Eemian interglacial, about 125,000 years ago, was warmer than our current Holocene. These brief interglacial periods usually last 10 to 15,000 years. Our current Holocene interglacial is about 11,000 years old. As temperature rose and fell over the last 350,000 years, temperature led the rise and fall of CO2 by about 800 years. This meant that temperature was a causative factor driving this process, not CO2. The temperature and CO2 were correlated. As temperature rose, it slowly warmed the oceans. As the oceans began to warm, they outgassed dissolved CO2, much as a cold glass of Coke does when it is removed from a refrigerator. Conversely, as temperatures dropped, CO2 dissolved from the atmosphere into the oceans as they became colder. The recent rise in CO2 to 420 parts per million today is due primarily to the rapid rise in CO2 emissions from the burning of fossil fuels. This is something new. The CO2 concentration has not been this high for several million years. The temperature and CO2 correlation pattern prior to the Holocene has been disrupted. This raises a question: does this sudden rise in CO2 pose a significant threat to the future of life on our planet? According to the IPCC Executive Panel and its supporters, the answer is yes. We already have too much CO2 in our atmosphere, and we are at a significant risk of an imminent global warming apocalypse. Before we explore this issue further, we should perhaps look first at the flip side of this question. Can we ever have too little CO2 in our atmosphere, and can that be a threat to life on our planet? At the last ice age maximum 21,000 years ago, CO2 concentration dropped to 182 parts per million. This low level of CO2 was a definite threat to life on our planet. If the CO2 concentration had dropped further to 150 parts per million, most photosynthesis on the planet would have shut down, and most life on the planet would have died. We came very close to reaching that critical 150 part per million level of CO2 21,000 years ago. As CO2 was dropping toward the 182 part per million level at the last ice age maximum, it was already having an effect on life on the planet. Vegetation in the high plains of North America and Asia began to die off due to the lack of CO2, producing large dust storms in the northern hemisphere. These dust storms in the northern latitudes would begin to coat the glaciers and ice sheets with dust, thereby changing their albedos from being reflective of incoming radiation from the sun to becoming absorptive of incoming radiation. This change in albedo would have been a positive feedback mechanism boosting the melting process that was already being driven by the Milankovitch cycles. Figure 6 shows what the ice age maximum looked like 21,000 years ago. The depth of the ice sheet in the Toronto area was 2.1 kilometers. The superimposed height of the CN Tower at 1/4 of the depth of the ice sheet shows how puny man's efforts can be compared to the forces of nature. The other cities had ice sheet depths of 0.9 kilometers in Chicago, 1.25 kilometers in Boston, 3.3 kilometers in Montreal. A similar ice sheet today would be a true climate apocalypse in the northern latitudes that would cause immense dislocation, suffering, conflict, starvation, and death. The Laurentide ice sheet, which covered these cities 21,000 years ago, stretched from Alberta to the Atlantic Ocean. The Cordilleran ice sheet stretched from the Rockies to the west coast. It left only the highest mountains on Vancouver Island above the glaciers in the Strait of Georgia and the Strait of Juan de Fuca. There were no forests, no salmon runs, and no people. Similar glaciers and ice sheets covered Greenland, large areas of Europe, Asia, and the Antarctic. The large volume of water stored in the glaciers and ice sheets caused the sea level to drop about 150 meters. If all the glaciers and ice sheets remaining in the world today melted, the sea level would rise about 70 meters above its present level. These extraordinarily disruptive changes in sea level in the past were all due to the operation of natural forces, not man. These same natural forces are still in play today. The focus in Figure 7 is on CO2 levels over the past 600 million years. This gives us an opportunity to look for evidence of dangerously high levels of CO2 concentration that may have occurred in the past. The dashed line across the bottom of the graph shows a recent CO2 concentration level of 380 parts per million. As was mentioned in Figure 5, the CO2 concentration dropped to 182 parts per million 21,000 years ago. 300 million years ago, the planet was in the grip of the Karoo Ice Age, which lasted about 90 million years. The temperature and CO2 concentrations in the Karoo Ice Age were similar to those 21,000 years ago, with both temperature and CO2 being at their lowest levels in the past 600 million years. These two ice ages represented severe temperature and CO2 challenges to the survival of life on much of our planet. The Eocene maximum, 52 million years ago, that we looked at in Figure 1, had one of the highest temperatures in the past 600 million years. This occurred when the CO2 level was about 1,000 parts per million. The average CO2 concentration over the 600 million year time period of this graph was about 2,600 parts per million, or about 6 times higher than today's level. This illustrates that there is no fixed relationship between CO2 levels and temperature over long periods of time. In the Cambrian period, 530 million years ago, there was an explosion of complex new life forms in the oceans. This was the first time that fossils were created that were visible to the naked eye. The CO2 concentration was about 7,000 parts per million. This is far above the 420 parts per million concentration that we are worrying about today in terms of global warming and its potential effect on the survival of species. With regard to the impact of CO2 levels on humans, common CO2 concentrations in confined spaces like theaters, shopping malls, and in many commercial greenhouses is about 1,200 parts per million. It is striking that these CO2 levels are at about the same CO2 level as was present at the Eocene maximum at a time when the Earth was ice-free. On submarines, CO2 scrubbers are activated to keep CO2 concentrations below 5,000 parts per million. When we are outside in open areas, we inhale CO2 today at a concentration of 420 parts per million, and we exhale CO2 at a concentration of 40,000 parts per million. That is a 100-fold increase. People do not complain or show distress about the 40,000 part per million level of CO2 in their lungs just as they are about to exhale. These various values of CO2 over the past 600 million years suggest that there is little reason for us to be unduly alarmed over our current CO2 level of 420 parts per million. In Figure 8, we look more closely at events in our Holocene interglacial period. But before we get further into climate change issues, I would like to say a few words about our species and what it has been doing during the Holocene. This can help to give us some perspective on the climate issues that we are dealing with today. Agriculture began about 11,000 years ago. The population of our species at that time was estimated to be about 10 million people. Our forefathers were hunters and gatherers living in small scattered bands that survived the last ice age maximum 21,000 years ago. The development of agriculture marked a momentous step forward in human development, leading to a steadily increased food supply and to the ability to store foods over long periods of time. By the Roman era, 2,000 years ago, the population had expanded to about 300 million people. With improved food supply, our forefathers began to live in settled communities, which became towns, cities, and nation-states. They learned about the division of labor and how to specialize in tasks, leading to better tools and to the development of cultures. They learned how to build pyramids and aqueducts and to establish academies to study philosophy, mathematics, and the nature of the natural world. They also learned, unfortunately, how to wage wars of conquest and plunder. For the losers in these wars, the prospects were often bleak: quick death or slavery. By the 1920s, our population was about 2 billion people. By then, we had determined the dimensions of our world and had colonized most of it. We had learned how to exploit the energy and fossil fuels and to create an industrial revolution that led to a rapid increase in the standard of living in the industrialized countries. We had learned how to fly, and we had already experienced our First World War, which drastically affected the lives of millions of people and the collapse of empires. Today, our population is about 8 billion people. We have gone to the moon, and we have developed an enormous body of knowledge about ourselves, our planet, the solar system, and space. We have also had our Second World War, and have learned how to build and deliver hydrogen bombs. It is clear that we still have many flaws, but overall, we are a remarkable species. On a geological timescale, 11,000 years is only the blink of an eye, but within that period, we have gone from being an insignificant species to being the dominant species influencing events on our planet. We have gone from a rudimentary agriculture 11,000 years ago to developing Chat and GPT artificial intelligence today. It is an extraordinary accomplishment. Population growth and climate change are tightly intertwined divisive issues today. One noteworthy development is that in all the countries that have industrialized and have raised their standard of living, they now have birth rates by their native populations that are below replacement levels, and sometimes by a significant margin. All countries that have successfully industrialized have had ready access to reliable and affordable fossil fuel supplies. All countries that wish to retain high standards of living in the future must continue to have ready access to reliable and affordable energy resources. This suggests that perhaps the most humane way to stabilize the world's growing population and deal with the problems that it engenders is to rapidly raise the standard of living in all the developing countries. This requires that all these developing countries must find ways to get ready access to reliable and affordable energy resources. Current green energy technology, however, is not reliable and cannot meet the energy needs for developing countries wishing to develop modern industrial economies for the benefit of their citizens now or in the foreseeable future. And therein lies one of the major dilemmas that is confronting our species today. This is at the heart of the political debate that is underway over climate change issues and the desire of billions of people in the developing world who are seeking a better standard of living than they presently have. We will return later to further examine this question and its implications. And now, back to climate change to see what further insights we can gain into whether or not the planet is at risk of a climate crisis from rising CO2 emissions. At the Holocene climate optimum about 7,000 years ago, summer temperatures in Canada were as much as 4 degrees Celsius above present. Most glaciers and the last remnants of the ice sheets disappeared. The tree line moved north. At Tuktoyaktuk on the shores of the Arctic Ocean, there was a spruce forest. It is all tundra today. Cattails and sweetgale grew in the wetlands in the forest at Tuktoyaktuk. The northern limit for cattails today is several hundred kilometers to the south. These physical details provide strong evidence that temperatures were significantly higher 7,000 years ago than they are today. Today's temperatures are not unprecedented when proxy data from the Holocene climate optimum is also considered. It is interesting to note that polar bear DNA has been traced back to about 500,000 years ago. This means that polar bears survived the higher temperatures of both the Holocene climate optimum and the even higher temperatures of the Eemian interglacial. Polar bears do not seem to be at any risk of imminent extinction today due to our current global warming. The green graph in Figure 8 is the average of 6 boreholes. It defines the overall temperature trend on the Greenland ice cap and the Canadian archipelago during the Holocene. The green line is a good example of the Milankovitch cycles in action. The precession cycle topped out about 12,000 years ago. The tilt cycle topped out about 5,000 years ago. The combined action of the three Milankovitch cycles is now downward, and it will continue downward for about the next 14,000 years before a minor reversal occurs. It is this downward path of the Milankovitch cycles that likely initiated the start of a new period of glaciation about 5,000 years ago. The red graph is from a single borehole, but it is confirmed by other proxy data from other sources. It shows in more detail the roughly 1,000-year cycles of temperature fluctuations throughout the Holocene. The Minoan warm period, the Roman warm period, and the medieval warm period were noted for their good crops and creative human developments. The temperature dips following these highs, especially at the bottom of the Little Ice Age about 300 years ago, were times of great turmoil and hardship. As conditions worsened in the Little Ice Age, suspicion grew that diabolical forces were at work. A consensus developed that witches must be the source of all the starvation and misery that people were experiencing. This soon became a widespread hysteria, leading to witch trials, coerced confessions, and to the cruel deaths of thousands of innocent women. The persecutions were particularly cruel and numerous between 1588 and 1600, and between 1620 and 1650, which were the times of the most extreme cold and the most dreadful storms. We emerged from the Little Ice Age about 1860. We are fortunate to now be living in our current, moderate, modern warm period. Figure 9 shows yearly sunspot numbers. The Maunder minimum and the Dalton minimum were two particularly cold periods in the Little Ice Age. They were noted for their great crop losses, widespread starvation, and for the fact that there was little or no sunspot activity during these very cold periods. It has been realized since then that sunspot activity is linked to regular variations in the magnetosphere of the sun. When the magnetosphere is strong, the solar wind emanating from the sun partially blocks the flux of cosmic rays coming into the upper atmosphere, where they create cloud condensation nuclei. This reduces the formation of clouds and the albedo of the Earth, allowing it to receive more incoming radiation from the sun, thereby warming the Earth. The sun's magnetosphere has doubled in strength since 1900. This is likely a major cause of most of the warming that has occurred since 1900. Variations in the magnetosphere of the sun are also the most likely explanation for the roughly 1,000-year warming and cooling cycles that we saw in the red curve over the Holocene. When the sun's current warming phase ends and it goes into another cooling phase, this will become another negative natural force affecting climate change, in addition to the downward trend that is already underway with the Milankovitch cycles. This is the next downward step to be expected from the green graph shown in Figure 8. If this happens, it will likely create an even more severe set of weather challenges for the population than was experienced by those in the Little Ice Age. At least by then, they will know the witches are not the cause of their troubles. The IPCC has largely ignored the behavior of the Earth's magnetosphere and its effect on cloud formation and the resultant warming and cooling of the Earth. They have focused instead on variations in solar irradiance, which varies by only a small amount over time. On a side note, Dr. Henrik Svensmark, who was head of the sun climate research at the Danish National Space Center, developed much of the theory of the effect of the sun's magnetosphere on cloud formation and the effect that this has on the Earth's climate. He was joined later in his research by Dr. Nir Shaviv, an Israeli astrophysicist who was investigating what effect the incoming flux of cosmic rays and iron meteorites into the Earth's atmosphere has on climate change on Earth. Dr. Shaviv found that the flux of cosmic rays and meteorites had a notable increase in strength about every 150 million years. This coincides with today's current ice age, also with a sharp temperature drop about 150 million years ago, with the Karoo Ice Age 300 million years ago, and with another sharp temperature drop about 440 million years ago. Each of these drops in temperature coincided with our solar system passing through one of the spiral arms of our Milky Way galaxy and of being exposed to a higher flux of cosmic rays and iron meteorites in the process. This increased flux of cosmic rays penetrating into the upper atmosphere likely created more cloud cover and a higher albedo, causing the Earth to cool. It is an interesting theory, as it could also explain two possible incidents of snowball Earth conditions occurring prior to 600 million years ago. In summary, natural forces have had major effects on climate change in the past. Until some significant change occurs in the location of the continents, or in the location and size of current mountain ranges, or in the radiation received from the sun, or in the flux of cosmic rays coming into our upper atmosphere, we will likely remain trapped in our current ice age. The scientific method. Hypotheses must be reproducible. Hypotheses must be verified by observation or experiment. Hypotheses remain conditional truths, always subject to further confirmation in the future. Comment by Albert Einstein. No amount of experimentation can prove me right. A single experiment can prove me wrong. Comment by Richard Feynman. It doesn't matter how beautiful your theory is. It doesn't matter how smart you are. If it doesn't agree with experiment, it is wrong. The scientific method has been the gold standard for distinguishing between a belief and a fact for 400 years. It has served us well. The information that I have presented so far is by scientists using standard procedures of the scientific method to collect, analyze, and disseminate their findings. Post-normal science. PNS is sometimes used in situations where the facts are uncertain, values are in dispute, stakes are high, and decisions are urgent. PNS relies on a consensus of experts to provide the governing assumptions, equations, and data to be analyzed in each study. PNS was used successfully in the creation of the atomic bomb in the Manhattan Project in World War II. PNS was a failure in the Club of Rome's Limits to Growth study in 1971. The study predicted that the planet's major energy and material resources, including food, would be exhausted by the early 2000s. These predictions were all found to be wrong by 2010. The IPCC studies are based on PNS procedures. The IPCC mindset. In 1987, the Brundtland Commission issued its influential report on sustainable development, which supported a precautionary principle approach to environmental issues. In 1988, Prime Minister Gro Brundtland was a keynote speaker at a Toronto conference to discuss the focus for the IPCC's upcoming climate study. She said, "It is established beyond doubt that we will experience a global change in climate. Humanity is conducting an unintended, uncontrolled, globally pervasive experiment whose ultimate consequences could be second only to a global nuclear war." The rhetoric of Prime Minister Gro Brundtland was of high alarm, of looming dire consequences, and of the need for swift action to address an imminent crisis. Our planet was at risk from a global warming apocalypse. Over the past 36 years, successive UN Secretary Generals, the IPCC Executive Panel, successive COP conferences, and almost all the environmental NGOs have sought to maintain a high level of alarm and fear over global warming issues. They have largely succeeded in achieving their goal. Brundtland's assumptions in 1988 were wrong. They are still wrong today. Her beliefs, however, were shared by many people, and these beliefs helped to launch the IPCC studies on a flawed trajectory. After 1988, a flood of money poured into green energy studies by universities and consultants. These studies were often blinkered, biased, and were based on a key IPCC assumption that rising CO2 emissions would produce a strong positive water vapor feedback response. There was virtually no funding available for more balanced and objective studies on what role CO2 might actually be playing in the atmosphere and the oceans. The inclusion of the precautionary principle in many IPCC modeling studies led to a focus on extreme scenarios and doomsday outcomes that fanned the growing hysteria over the perceived threat that CO2 was causing a global warming apocalypse. The IPCC approach is a classic example of the distortions that government-funded science can cause when seeking to justify desired political goals by looking at only one side of an issue. Figure 10 shows the Keeling curve for observed CO2 concentrations at Mauna Loa. Most observers agree that CO2 emissions from fossil fuels are the main contributor to this exponential rise in CO2. Greenhouse gases in descending order of importance are water vapor, carbon dioxide, methane, nitrous oxide, and ozone. The IPCC's hypothesis is that anthropogenic emission of CO2 and the other minor greenhouse gases produces a strong positive feedback response from water vapor, which then becomes the main driver of global warming. Thus, CO2 is acting as a global thermostat, controlling the rate of global warming by controlling the amount of water vapor in the atmosphere. This assumption, if true, coupled with the exponential rise in the CO2 curve, means that CO2 today should be a significant cause of climate change. This means that we should be able to see a significant correlation today between CO2's behavior and the various climate parameters. In the past 36 years of IPCC studies, however, this hypothesis has never been supported by reliable scientific observations or experiment. Figure 11 shows the 362-year-long Central England temperature record in red. It is the longest instrument temperature record in the world. The Central England temperature record is predominantly a linear trend, rising at an average rate of 0.28 degrees Celsius per century. The blue line is the estimated human-generated CO2 emissions into the atmosphere since the start of the Industrial Revolution, about 1750. 91.4% of the estimated CO2 emissions occurred after 1946. The lack of any obvious correlation between the rising CO2 emissions and the temperature record invalidates the IPCC's modeling hypothesis that CO2 is the major driver of recent temperature change. Figure 12 shows that the global sea level has been rising about 20 millimeters per decade since about 1860. This is a confirmation that we are currently in a warming trend that is causing glaciers to melt. The IPCC's modeling, however, predicts that we should be experiencing unprecedented global warming from rising CO2 levels, leading to an unprecedented melting of glaciers and to an unprecedented rate of rise in global sea level. The observed data, however, shows a relatively orderly linear rise in sea level from about 1860 through to 2014. There was no significant change in the rate of rise after 1946. This finding further invalidates the IPCC's modeling hypothesis that rapidly rising CO2 emissions are causing an unprecedented recent rise in sea level. The 330 millimeter height of the geologist's pick on the right shows the amount of sea level rise over 154 years. This is not an alarming rate of rise. It can be readily dealt with by raising dikes and by zoning regulations. The IPCC computer models claim that the strongest evidence of rising CO2 levels causing global warming will be found in the tropical troposphere 18 kilometers up in the atmosphere. The red curve in figure 13 shows the temperature rise that should be occurring in the tropical troposphere according to the IPCC's computer models through to 2025. The observed green satellite data and the blue weather balloon data at the bottom of the graph show the actual temperatures that were being measured in the tropical troposphere through to 2014. The IPCC's models are running too hot. The IPCC's assumption that CO2 produces a strong feedback response from water vapor is not supported by the satellite and balloon data. The IPCC computer models are not providing reliable data for governments to use in determining long-term climate policies. When the IPCC released its AR5 summary report for policymakers in 2014, it stated, "Human influence on the climate system is clear. It is extremely likely, 95 to 100% probability, that human influence was the dominant cause of global warming between 1951 and 2010. This was an extraordinary statement for the IPCC executive panel to make, given the clear discrepancy between the IPCC's modeling results and the observed data. As Richard Feynman observed, it doesn't matter how beautiful your theory is, it doesn't matter how smart you are, if it doesn't agree with experiment, it is wrong." The IPCC executive panel and its supporters claim that the planet is experiencing unprecedented recent changes in extreme weather. The observed records of tropical storms and hurricanes in figure 14 do not show any noticeable recent change in trend of the global frequency of either tropical storms or hurricanes over 50 years of record. This refutes the claim that we are experiencing unprecedented recent changes in extreme weather, at least with regard to tropical storms and hurricanes. The cost of hurricanes has increased over time, but that is due to more people and infrastructure being located in vulnerable areas. This is a land use issue, not a rising CO2 issue. Figure 15 shows that the frequency of major U.S. tornadoes has decreased over the past 72 years. This is showing a negative correlation with the rising red CO2 concentration curve at this time. This refutes the claim that we are experiencing unprecedented changes in extreme weather, at least with regard to tornadoes. The damage and cost of tornadoes has increased, but that is due to more people and infrastructure living in vulnerable areas. This again is a land use issue and a building standards issue, not a CO2 issue. A few years ago, IPCC computer modeling studies predicted that snow cover would soon be a thing of the past in the Northern Hemisphere. Figure 16 shows that snow cover can vary quite a bit from year to year, but there's no evidence from 52 years of record of any significant recent change in trend underway in snow cover. This refutes the claim that we are experiencing unprecedented changes in extreme weather, at least with regard to snow cover. Figure 17 shows that the 1930s was clearly the time of the most intense hot days in the US in the past 105 years. Today's observed intense heat records are similar to what they were 100 years ago, at least through to 2020. Figure 17 contradicts the claims by the IPCC and its supporters that we are currently experiencing unprecedented intense modern warming. In the earlier graphs, we were looking for changes in regional or planetary climate data. If we look at local weather records, however, we see that the creation and growth of cities can cause a significant rise of several degrees between local temperatures within cities and temperatures in the surrounding countryside. Many citizens claim that they are experiencing warmer temperatures than in the past. If they are living in growing cities, they are right. The addition of more buildings, blacktop, air conditioners, commercial and industrial activities, ground transportation, and airports results in the absorption of more solar heat and the generation of more anthropogenic heat in local areas that become urban heat islands. Figure 18 shows how the transition to a city environment can create microclimates that degrade the quality of the data that is collected by weather stations. This makes it difficult to determine what part of any change in a long-term temperature record in a city is due to climate change and what part is due to land use changes. The National Weather Service criteria for weather stations collecting temperature data states in part, when possible, the shelter should be no closer than 4 times the height of any obstruction, tree, fence, building, etc. The sensor should be at least 100 feet from any paved or concrete surface. In Figure 18, this weather station in the fenced-in enclosure is sitting on a paved road with concrete pavements on either side of the road. It is ironic that the building in the background is the University of Arizona Atmospheric Sciences Department. This weather station was part of the U.S. Historic Climatology Network, USHCM, which means that it was likely established in what would have been a rural environment about 100 years ago. It was decommissioned shortly after Anthony Watts, a prominent meteorologist, included it in a survey he did of USHCN weather stations in 2009. He concluded that about 89% of the weather stations did not meet NWS criteria for acquiring good quality weather data. Watts updated his study in 2022. This time he concluded that 96% of the weather stations failed to meet NWS quality criteria. Weather agencies claim to be able to adjust for this flawed data, but this is a dubious and contested claim. It seems, in fact, that the more the weather agencies adjust weather data without giving clear explanations of why and how the adjustments are being made, the more confusion and uncertainty they create about the reliability of the data that they do publish. The National Climate Data Center, NCDC, has created a new U.S. Climate Reference Network, USCRN, to deal with the issue of urban heat islands and the distorting effect that they can have on long-term temperature records. They have created a small number of new high-quality weather stations across the country in locations that are not likely to change in character in the next 50 years. The new USCRN network has been in operation only since 2005. This is a short period of time, but it has already produced at least one interesting result. Despite all the claims of unprecedented climate warming over the past 20 years, Figure 19 of the average monthly temperature anomalies in the USCRN network itself is not showing any pronounced upward trend in the temperature data from areas that have been selected to be free of any local city-induced warming effects. This may surprise many people, since their daily lives are dominated by the urban environments that they are living in. What they may not appreciate is how small the urbanized areas are compared to the total surface area of the Earth. Water covers about 71% of the Earth's surface, land about 29% of the Earth's surface, and urbanized areas about 1 to 3% of the land area, which is less than 1.2% of the Earth's total surface area. This appears to be too small of an area to be having a significant effect on climate statistics for regional areas or for the planet as a whole. This is why we are not seeing any significant recent uptrends developing in the graphs for temperatures, sea level rise, hurricanes, tornadoes, snow cover, or intense periods of heating. Urban heat islands do affect the lives of millions of people who live within them, but they largely adapt by relying on more air conditioning to remain comfortable in their daily lives during the hot spells. Figure 20 shows the wildfire acres burned annually in the U.S. Forest management practices brought wildfires largely under control after 1930, with fire suppression measures, logging, and controlled burns of forest litter. During the 1980s and 1990s, thinking changed, and opposition grew to logging and to having controlled burns of forest litter on a regular basis. In the 1980s and 1990s period, in semi-arid areas like California, South Australia, and the Okanagan Valley here in BC, more subdivisions were allowed to be developed in forested areas. Forest litter accumulates in these areas adjacent to homes. When fires do occur in these areas, property damage and loss of life can be high. Poor maintenance of power line rights-of-way in California and Hawaii have also contributed to serious destructive fires in recent years, as has human carelessness. These are primarily political, land management, and people issues, not CO2 issues. Figure 21 shows the global decline of the acreage burned by forest fires per decade in orange, and the rising CO2 emissions over the past 100 years in the blue curve. The correlation between the two curves is negative. In any given year, some areas of the world with forests, which have a lot of forest litter present, can be hit hard with a combination of high temperatures and dry conditions, which can cause an extremely bad year for forest fires, as Canada experienced in 2023. This, however, represents a short-term local anomaly in a long-term global decline in the forest fire acreage that is being destroyed annually. 2023 was expected to be a hot year because of El Nino. But this naturally occurring phenomenon appears to have been further boosted by the large Hunga Tonga volcanic eruption in the South Pacific in 2022. That eruption injected large amounts of water and water vapor, which is the strongest greenhouse gas, into the upper atmosphere, adding to global warming. It may take several years for the heat-creating Hunga Tonga effect to fully dissipate. This chart is an example of the widespread successful adaptation measures being taken by most nations in the world to reduce the damage from forest fires. Increased population, increased infrastructure, and emergency fire suppression costs when fires do break out are the primary reason for the cost of forest fires increasing, not rising CO2. Figure 22 shows that CO2's ability to absorb outgoing radiation from the Earth into space decays exponentially. By the time CO2's concentration in the atmosphere rose from 0 parts per million to 60 parts per million, most of CO2's potential capacity to warm the Earth had already occurred. The Figure 22 graph was prepared in 2009. You can see that at our present-day concentration of 420 parts per million, adding more CO2 to the atmosphere has little effect on global warming. The red graph in Figure 23 shows the deaths from non-climate related events, earthquakes, tsunamis, volcanoes, over the past 100 years. The average death rate per decade is holding below 50,000 deaths per year. The blue curve shows the remarkable reduction by over 90% in the past 100 years in the number of lives being lost to climate-related events per decade, from floods, droughts, storms, wildfires, and extreme temperatures. This reduction is due in large part to the growing wealth and knowledge of societies and governments, which have, 1, established monitoring systems to detect and track extreme weather events, 2, devised warning procedures to alert local authorities and citizens of developing threats, 3, organized temporary evacuation measures in floods and hurricanes, 4, organized hydration and temporary cooling measures in heat waves in countries where citizens cannot afford air conditioners, 5, issued zoning regulations to limit development in hazardous areas, and 6, funded various structural measures such as flood protection works to greatly improve the safety and welfare of their citizens. This remarkable improvement has happened as the world's population has risen from 2 billion people to 8 billion people in the past 100 years. It is an extraordinary testament to our species' ability to adapt to changing circumstances. Pursuing these types of meaningful local measures will be a much more effective way of dealing with future climate change problems as they arise and where they arise, rather than trying to pursue a worldwide ban on CO2 emissions, which will produce only great social and financial pain for negligible gain. CO2 is an essential requirement for all life on the planet. It produces faster, stronger, more drought-resistant growth in plants. Figure 24 shows the growth of a pine sapling in the left cubicle, kept at 385 parts per million CO2 over a 10-year study period. Each cubicle to the right shows similar pine saplings grown in cubicles with successively higher increments of 150 parts per million of CO2 over the 10-year study period. It is clear that today's low CO2 concentration is starving trees and plants of the food they need to achieve their full growth potential via photosynthesis. Figure 25 shows the results of a large international study in 2016 of 35 years of satellite records, which determined that there has been a net greening of the planet by plants and trees equivalent to 2 times the area of the continental United States. Rising CO2 levels are also contributing to the record crop yields that the Earth has experienced in recent years. CO2 provides a major benefit to all life on our planet. CO2 is not a pollutant, despite the claims by the US EPA and by most Western governments who are trying to regulate CO2 out of existence. Conclusion. The IPCC's assumption that CO2 is a thermostat controlling climate change is not supported by data or analysis. Natural forces play a major role in climate change. The planet is in a moderate modern warm period, similar to the earlier medieval warm period and the Roman warm period. The warming is being driven primarily by the sun, not by CO2. CO2 emissions are helping to green the planet and improve crop production. CO2 is not a pollutant. The combined action of the Milankovitch cycles has turned negative. Technically, the planet remains in the grip of an ice age that began 2.5 million years ago. We do not know when this ice age will end. The planet is not at risk of a catastrophic global warming apocalypse within the foreseeable future. Postscript. Western societies have driven the process to develop the Paris Accords and to achieve the net zero CO2 emission goal for fossil fuels by 2050. Hundreds of billions of dollars have been spent on green energy studies to achieve this goal. Initial estimates are emerging that full implementation of the net zero 2050 goal could cost hundreds of trillions of dollars. Jurisdictions leading the conversion to replace fossil fuels with green energy are rapidly becoming high-cost, highly taxed, highly subsidized, and highly indebted jurisdictions. These same jurisdictions are experiencing economic stagnation and deindustrialization, impacting the lives of those with the least income and job security. Tariffs are now being considered by several jurisdictions to retain some residual manufacturing capacity. All these costs and disruptions to be expected from current green energy policies are being justified by Western governments and environmental NGOs as being necessary to save our planet from a global warming apocalypse. As this video has shown, however, there is no looming global warming apocalypse threatening our planet, and that rising CO2 emissions are proving to be a benefit to the planet's food production and a negligible threat to global warming. In a rational world, this would be welcome news. It would mean that our current major misallocation of our financial and intellectual resources in pursuit of inefficient, unreliable, and damaging green energy measures could be stopped. It would also mean that developing countries could more readily access fossil fuels to industrialize their economies and raise the standard of living of their citizens. This could stabilize the growth of the world's population in a humane way and perhaps lead to an orderly, gradual decline of the world's population in the future. A turnaround in current energy and economic policies of this magnitude would free the world from the growing threats of the disorder, strife, and economic ruin that lies down the path that Western countries are pursuing with their net zero 2050 policies. This much-needed change in policies may not happen, however, since we are no longer living in a rational world. We are living instead in a self-induced climate hysteria that has gained enough momentum, believers, and financial beneficiaries that it may take a general economic collapse of the West, with all its accompanying social unrest, to eventually bring us to our senses. Our great need today is for new people in leadership positions who have both wisdom and integrity and a willingness to challenge existing dogmas. And on this rather somber note, the video ends. If you know of others who might be interested in the video, please send them a link to it and to the transcript and references as well. My email is as shown. The end. Thank you for watching.